in the first section, we were reintroduced to what makes a graph move left, right, up, and down, and that matched with our activity in the beginning. What we do for the rest of this unit is look at what do other values do to your graph. What happens when there is a negative in a graph? What happens when you multiply numbers in a graph? So we get all the possible situations. So what I would like you to do is off to the side on this one is make an extra note. So we'll start with y equals f of negative x. So if the negative is inside the function, so again we're using that language of inside and outside. If it is inside the function, in other words, it's with the x, then the negative affects the x coordinate. And if you imagine a point, and I'm going to just label this one randomly, it looks like it's at 3, 2. If the negative affects the x coordinate, what's going to happen is that 3, 2 is going to become negative 3, 2. The entire effect of this is the negative affects the x coordinate, and the graph is reflected over the y-axis. So if the negative is inside the function, that negative is with the x, and so we multiply our x values by a negative 1, and the effect is that graph gets reflected or flipped over the y-axis. Similarly, we'll make a note when the negative is outside of the function. So if it's outside the function, and sometimes people say that it's with the y because I could multiply both sides by a negative sign here and move the negative to the other side. Does that make sense? So whereas our first one, oh, somebody else has math. Okay, in our first one, we say the negative is with the x. In this one, we could say that the negative is with the y if we rearranged it. But generally, just like before, I like to keep my y equals by itself, so we'll have our negative on the right-hand side. So if the negative is outside the function, then it affects whoa, that's too many O's. Oh well. The y coordinate and the graph is reflected over the x-axis. So if we think about the picture above, and we think about that same point being 3, 2, in this situation, I'll scroll back down in a second. Now our coordinate is 3, -2. Everybody good? Okay. Okay, so let's go to example 1. Again, we have a random graph of g of x. We want a reflection in the y-axis. So one of the things we'll have to do in questions is be able to translate a reflection in the y-axis. Imagine my y-axis is this one, right? The vertical one. And if I'm reflecting something over the y-axis, things are moving horizontally. It's my x value that's changing. But sometimes you might want to underline something like this and just make a note in function notation that that's f of negative x. The x, the negative, is inside. And so what's going to happen is all of our x values are going to get multiplied by a negative 1. So instead of having negative 3, 1, I'm going to have positive 3, 1. Instead of negative 1, negative 2, I have positive 1, negative 2. This point at 3, negative 2 would get reflected over to negative 3, negative 2. And this point at 5, 2 is now going to be at negative 5, 2. If we join the dots, can you see that the blue graph is a reflection of the red graph over the y-axis? State the domain and range of each function. So what I'm going to do is I'm going to color code things here. Again, the original graph was in red, and my image graph was in blue. So for my domain of my original graph, my smallest x value is -3. I'll use interval notation this time. My largest x value is 5. They're included on both of them, so it goes as an interval from -3 to 5. And my range, my smallest y value is -2. My largest y value is +2. Now we did a transformation. We did y equals f of negative x. And if we look at our graph to find the domain, now my domain goes from smallest value of -5 to biggest value of +3. And my range, smallest value of -2, biggest value of 2. Notice my range didn't change, because in my transformation, that negative is just with the x. My y values stay the same. So my range stays the same. Notice that my domain being from -3 to 5, if I multiply things by a -1, I get +3 and -5. And so things got flipped around that way. And the reason I want you to think about these things is because in this example that we just did, we were given the graph. And we can get domain and range right from the graph. But sometimes you won't be given the graph. Wow, that's a circle. There we go. The graph is gone. You won't be given the graph, but you will be given the range and domain of the red graph. Could you find the domain and range without the graph there? If I knew the original graph's domain was -3 to 5, and its range was -2 to 2, and I'm told that I reflected it over the y-axis, do these blue answers make sense even though we took the graph away? Okay? And so this is what the grade 12 course does. Sometimes they give you all of the information, sometimes they take away parts of it, and you still need to be able to think about, could I figure it out from there? But this one, we were given this graph, so there it is again, and domain and range from the graph is fairly easy. Okay, questions for practice on this one? are 3 and 13.